Hello students, I am Sonali Kelkar from City International School, and today we are doing the 7th revision of science. Today I am going to take the topic convex lens and concave lens as well as electric motor, and we will complete the revision of physics. Let's start today's session. So before we start with the ray diagram of convex lens, let's start with the rules that will help you to draw the ray diagrams. Okay, so let's read the first rule. It says that when light ray from the object is parallel to the principal axis, after refraction it passes through the focus. Okay, now after refraction from the convex lens, it passes through the principal focus on the other side of the lens. Now this is the other side. This is the other side of the lens. And as you can see, this light or this ray is coming from the object, and when it touches the, or when it passes through the lens, it gets refracted and then it goes through the focus. Okay. Now in convex lens we will consider that f2 is a prime focus or principal focus. Now the second case says that light ray from the object is passing through the principal axis. Now this is just reverse of the first case. Okay, when the light ray from the object passes through the focus, it passes through the focus after refraction from the lens, it emerges parallel to the principal axis, right? Now the third rule says that when light ray from the object is passing through the optical center, this is the optical center of a lens, right? If this is a line which is denoting the lens, then the center of this line is nothing but the optical center. And when ray passes through the optical center after refraction from the convex lens, it will emerge without any deviation. You can see the ray is not deviating anywhere, it is emerging as it is without any deviation. Okay, so you have to remember all the three rules before you start drawing your convex lens diagrams. Now the first case is where the object is at infinity. Okay, now object is at infinity. So whenever the object is at infinity, remember that you have to make the parallel rays which are coming from the object. So you can see the parallel rays coming from the object over here, right? So here we have taken two rays on the above the principal axis and the two rays below the principal axis coming from the object after refraction. So I would suggest you children to draw a line, okay, and then from this line you can start deviating the rays. After refraction they pass it through the focus. This is our rule 1. Okay, rule 1. So we follow the rule 1 here, and as you can see, because these all rays are actually meeting at f2, so definitely the object, the image over here is real. Okay, the image is real, and what is the position of the image? It is at f. Is it diminished? Yes, it is highly diminished. It is highly diminished, or you can say point size image. Okay, it is real, and all the real images are always inverted. Let's do the second. Here now I have brought the object near to the lens. Okay, here the object is near to the lens, still it is beyond 2f1. Okay, 2f1 and f1, it is on the front side of the mirror of the lens, and f2 and 2f2, this is on the other side of the lens. Okay, remember only these few things you have to remember. Now I have drawn an object. Okay, you have to put an arrow which shows this is the head of my object, and how you are going to name the object A and B. A and B, right? The top is, the head is A and the bottom is B. Okay, now the two rays are passing from the object here, and when it passes through the lens, there is a refraction. And because this ray was initially parallel to the principal axis, after the refraction it will pass through the focus as per the rule. And here we are going to take the third a rule over here. Okay, we have taken the first rule, rule number 1, and rule number 3, right? Rule number 3 says that this ray is passing through the optical center without deviating. It is emerging out on the other side, right? So wherever these two rays are crossing each other, meeting each other, you have to draw a image over there which is inverted. And here you can see this is real, this is inverted, and the size of the image is diminished, little diminished. Okay, let's take this third diagram. Here now my object is at 2f2. Okay, and what is the other name of 2f2? We can say it center of curvature 1. Okay, so at 2f2 my object is kept. Again, I am going to draw two rays. One ray is parallel to the principal axis. After refraction, it passes through f2. The other rays is passing directly from the optical center, emerging out as it is from the other side. Okay, and wherever these two rays are meeting, you are going to form your image, which is real and which is inverted. Why it is real? Because these two rays are, after refraction, these two rays are actually meeting. Okay, so whenever these rays are actually meeting, we say that a real image is formed, and real images are always inverted. Okay, now here I want to give you one tip, a very important tip when you get these type of diagrams where the object is placed at you can say 2f1, okay, in case of lenses, or center of curvature C in case of mirror. Okay, so I'll just give you the hint of how you are going to draw the diagram. So whenever you have to draw the diagram, so let's start with the diagram. You have to draw a line first. Okay, you can draw a line of about 12 centimeter, right? And take a midpoint of the line, that is 6 centimeter. Over here you can draw a straight line, and later on you can just give a small curves around this line. Okay children, you have to make as thin curve as you can, okay, because length has to be a thin one. Now on my this side I have 6 centimeter, right? 6 centimeter of line, and even on the other side I have 6 centimeter of a line, right? So over here you can make 2f1, over here you can write 2f2, right? What is the half of 6? 3. So here you can take f1, and here you can write f2. Okay, now because there is always a little problem of getting the image at 2f2. Okay, it is very difficult to get an image at 2f2. So what you have to do, you have to do little trick over here. I would suggest you to take a object. Okay, now here also the object, the height of an object should never be the half of the lens. Now what is half and half of the lens? Suppose this is my lens. Okay, I have taken this length, the height of this length I have taken, let's take 4 centimeter. Okay, 4 centimeter. Okay, this is one from here to here, 4 centimeter. So what is the half of 4 centimeter? 2 centimeter. And what is the half of 2 centimeter? Is 1 centimeter. Okay, so your object, height of the object, in this case you can take 1 centimeter. Okay, it shouldn't be, this object, height of the object should never be more than the half of the lens. Okay, so I have taken this object over here, and we know that there will be a image over here. So I'll draw an image over here. Let's take the height of this image also 1 centimeter, and I'm drawing this image right over here. Okay, now after you draw the object and the image at 2f1 and 2f2 respectively, then you start drawing the rays. Okay, Now the first ray is will be parallel to the principal axis. After refraction, it passes through the focus, right? It passes through the focus. So let's see how it passes through the focus. It passes through the focus like this, right? And the second ray will emerge from the optical center, goes as it is, and it going like this. So these two rays are crossing each other or meeting each other over here. So with the help of a proper scale, you draw this line, and try to meet these two rays right over here. So you will get this diagram. Otherwise, it is very difficult to get the image at 2f2. Now, how is the image? Image is of the same size. What is the position of the image? This is at 2f2. It is real, it is inverted. Now, the next is where the object is placed between 2f1 and f1. Between the center of curvature C1 and f1. You can say this also. So, whenever you take the object after the refraction, the light, the first initially the ray is parallel to the principal axis. After the refraction, it passes through the focus. My principal focus f2, and the other ray is passing from the optical center, and it is going to make down over here. Here you can see the image is quite enlarged. It is real, it is inverted, and it is magnified image, right? And where is the image is forming? Beyond 2f2. 2f2 is here, but the image is formed beyond 2f2. And the next case is where the object is at f1. Object is at focus. Now you can see the object is coming nearer to the lens. Step by step it is coming near towards the lens. And what about the image? Image was going away. Now in the last case, image was formed beyond 2f2, but here we can see the rays which is parallel to the principal axis passes through the f2, and the other one is passes through the optical center. And as we can see it very clearly, these two lines are parallel to each other. These two lines are parallel to each other, and we assumed that somewhere in the infinity these two rays are going to meet, because these rays will be meeting in reality. So we say that the image form will be highly enlarged, real, and inverted. So it is just an assumption. We know that parallel lines or parallel rays never meet each other, but it is just an assumption that maybe far at infinity they will meet. Next characteristic of the image in front of the lens, magnified and virtual erect. Now this is the last ray diagram of convex lens. Here what we have done, we have kept the object between the focus f1 and the optical center, right? When I kept the object between the focus and optical center, what I can see over here is a ray passing, the first ray which is parallel to the principal axis, after refraction passes through the f2. And the second ray, it goes directly from the optical center, it is going as it is. As you can see, these rays are not even parallel, they are moving in two different directions, right? They are not converging, they are diverging rays. You can see that these rays are diverging rays. They will never ever meet each other. So we have to extend these rays backward. I'm going to extend these rays backward. So these rays are extended backward. Both the rays are extended backward, and they are meeting somewhere at the back. And wherever they are meeting, our brain is going to our brain will visualize the object at that point, And how is the object? As you can see, the object is magnified, it is erect, and it is virtual, because these rays are not actually meeting. It is just an illusion that these rays are meeting at the back. Okay. Now this is a table which will give you a brief introduction or the brief study of the image formed by the convex lenses. Okay, we have already discussed all the ray diagrams of convex lenses. Wherever the object was placed, initially it was placed at infinity, then beyond 2f, then at 2f1, then between f1 and 2f1, then at f1, and between f1 and optical center. Okay, we have discussed about the position of the image, we have discussed about the size of the image, we have discussed about the nature of the image. So here I want to tell you one thing, children. Whenever you draw the diagram, ray diagram of convex lens, concave mirror, or convex mirror, whatever, you have to write down the position of the image, the size, and the nature of the image. Okay, never forget to write all these things in detail. Coming to the next, that is rules for making a ray diagram in case of concave lens. So let's start with the first rule. This says that the light ray from object is parallel to the principal axis when the this is the light ray which is parallel to the principal axis. This is my principal axis. Okay, and it gets after refraction from the concave lens. See, this is a concave lens. I'll draw a line over here. This is a concave lens. After refraction, you can see this ray is getting diverged. It is getting diverged, but it appears, okay, the ray appears to diverge from the principal focus. Okay, now the ray is getting diverged, but what we have to do, we have to extend it backward towards the focus, and now it appears that it is getting diverged from the principal focus located on the same side of the image. Now this f1 will be the principal focus located at the same side of the lens. Now the second is when light ray from the object is passing from the principal focus. When the light ray is passing from the principal focus, what is happening? After refraction from the concave lens will emerge parallel to the principal axis, right? After refraction, you can see it is actually emerging parallel to the principal axis. But this ray, you have to extend it till focus. That is principal focus. Okay. Now here, when the light from the object is passing through the optical center, it emerges to the other side as it is, okay, without any deviation. So these are the rules of ray diagrams in case of concave lens. So we have two diagrams in case of concave lens. In the first diagram, we have taken the object is at infinity, right? Okay, now here, because object is at infinity, so we have to take two rays coming from the object parallel to the principal axis, right? Okay, after refraction they are getting they are diverging, right? Because concave lens is a diverging lens. So concave lens is a diverging lens. So rays after refraction, definitely they are going to diverge, but because they are diverging, they are not going to meet, right? But what we have to do, we have to extend them backward. Okay, that is on the same side of the lens. We have to extend them backward because they were initially parallel to the principal axis. So when we extend them backward, they should pass through the focus. Okay, they should pass through the focus, that is principal focus. And because the rays are not meeting in reality, so definitely the image at focus will be virtual, and you can see it is highly diminished, virtual, erect, and highly diminished, and the position is the f1, that is the focus, right? Coming to the next diagram of concave lens. Here we can keep the object anywhere on the principal axis. Okay, here we have kept the object. Okay, between 2f1 and f1 we have kept an object. Okay, two rays are coming from the object. The ray which is parallel to the principal axis deviated after refraction. When it is being extended backward, it passes through the focus. Okay, then the other ray is just passing through the optical center. It is going straight, passing through the optical center without any deviation, and wherever these two rays are meeting, they are not meeting in reality, so definitely the image form will be virtual, will be erect, and will be diminished. So image form will be V, virtual, erect, and diminished. This is called Ved. Okay, and where we have done the Ved in case of mirror, we did in case of convex mirror. So if you see, the images of a concave mirror are quite similar to the convex lens, and images of convex mirror are quite similar to the images of concave lens. Okay, so here we can see the image formed by the concave lens. Object anywhere on principal axis, used in case of correcting myopic eyes. So these concave lens are used to correct the short-sightedness, that is myopia, in human beings, right? Characteristic of the image form will within focus, okay, virtual, erect, and diminish. So this is how we have to do our lens and their diagrams. This is a table which shows the image formation of concave lens. Now we will see the lens formula and the magnification, right? So the lens formula is 1 upon f is equals to 1 upon v minus 1 upon u, and the mirror formula is 1 upon f is equals to 1 upon v plus 1 upon u. This is my mirror formula, right? And this is my lens formula. So you try to remember only one formula, and the other is just opposite of the first one. Now magnification or produce is definitely, magnification is the height of the image denoted by h dash divided by height of an object, that is h. In some books you will find that height of image is denoted by hi and object is ho. So don't get confused. Height of the image and height of the object is the ratio, and this ratio is nothing but the magnification of the lens or magnification of the mirror. Now regarding the sign convention of the convex and concave lens. In case of convex lens, the object is always in front, and even in case of concave lens, the object is always at front. So definitely, or on the same side of the lens. We don't have to say front or back. On the same side of the lens, object is always on the same side of the lens. So my u is always negative in both the cases. V positive for real inverted and negative for virtual erect, right? So in case of convex lens, in most of the cases, the image was real and inverted. So whenever the image is real and inverted, the V, that is the image distance, is always positive, and whenever the image is virtual and erect, then the V is always negative. Okay. F is positive for convex lens and negative for concave lens. Convex lens, it is positive, and negative for concave lens. My F, the principal focus here, this was the principal focus of convex lens. It is on the positive side, right? If you draw the Cartesian also, it is on the positive side, whereas F1 was the principal focus in case of concave lens. So it is on the negative side of the Cartesian, so it is always negative. Height is positive when the image is virtual. When the image is virtual, it is always on the top of the principal axis. So height is positive, right? But real image will always have height negative, because real images are always inverted. Okay, so these things you have to remember. Now this is the drawing of electric motor. How to draw the electric motor? It is a very important drawing. Electric motor do come for the drawing. It do come for the working of electric motor and the principle of electric motor. So the principle of electric motor, it is, what is the principle of electric motor? When a current carrying conductor, this is a current carrying conductor, okay, when a current carrying conductor is placed in the magnetic field, then the force is applied on the current carrying conductor. Okay, when the current carrying conductor is placed in the magnetic field, then the force is applied on the current carrying conductor. Okay, if this force is going to move the current carrying conductor, which is also very important. A force is applied on the current carrying conductor which will make the current carrying conductor to move. Fine. So this is all about the principle of electric motor. And what about the drawing of electric motor? Let's draw the electric motor, then we will discuss about the working of electric motor, right? So to draw the electric motor, you can draw it very easily. You can draw first the two magnets over here, and you can label side by side. This is the north pole of the magnet, this is the south pole of the magnet, right? Two magnets are there, north and south pole, and two triangles are done, right? Here what you can do is you can draw another rectangle like this. We have made initially the two rectangles. Okay, this is half done rectangle. It is easy. Now this is going to attach with the split rings, right? And what is the other name of split ring? We call commutator. Why do we call commutator? Because it changes the direction of the current. Commutators are the device which changes the direction of the current. Now I'm drawing a brush, and these are the the threads of the brush. Here also I'm going to draw a brush, and these are the thread of the brush, right? I'm going to attach this brush to the battery. If you want to put a key over here, you can put a key, right, and attach to the brush, right? Now this current carrying conductor, I will name it as A, B, right, C and D. Fine. And this is the positive terminal, this is the negative terminal. This will be my brushes. Let me name it as B1 and B2, and this commutator as C1 and C2. And I have to show the flow of the current because this is the positive terminal, so definitely the current is going to flow like this. It is going to flow like this, like this, like this. It will come and it will go from AB to CD, and from CD to back to C2, and from C2 to B2, and here is my circuit is getting completed, right? Now what about the direction of the force? Okay, to find out the direction of the force, what we have to do is we have to use the left hand, Fleming's left hand rule. Okay, left hand rule. So left hand rule will, what does it show? That it shows that direction of the thumb shows the direction of the force, right? Then my other finger, okay, what you call the index finger, shows the direction of the magnetic field, and that middle finger will show the direction of the current. Okay, so what did I tell you? How you are going to learn it? Father, mother and child. Okay, so this is how you can learn, and you have to place the middle finger, which will show the direction of the current. This is my direction of the current. Okay, then direction of the magnetic field and the direction of the force, right? So at North Pole the force is acting downwards, so when the current passes through the ABCD loop, okay, then this AB will go down. This AB, whole ABCD, how the current is flowing. So the current is flowing through A, B, C and D, right? So in this case, initially this AB will go down, this AB will go down over here, okay, the whole thing will go down, and DC will go up, DC will go up, and it will make a, like, it will move at 180 degree, it will move at 180 degree, okay, it will move at 180 degree, but it will stop here, because to make them to move up and down, okay, I need to change the direction of the current. Okay, I need to change the direction of the current, and that is why we have put a split ring over here. Okay, the split rings are over here, and which are attached to B1 and B2. Okay, so as soon as this whole thing, there should be axle over here, right? As soon as my C2 comes here and C1 comes here, the direction of the current changes, right? The direction of the current changes, right? And what will happen? Now this DC will come on the North Pole side, and what AB will come on the South Pole side. Okay, now DC will go down. Initially the DC has went up. Now the DC will go down. Okay, the DC will go down, and when the DC will go down and AB will go up, then it will going to make, then it will go, DC will go down, AB will go up, then the whole 180 degree, that is 180 and 180, 360 degree circle will be completed, right? And this is how this motor will keep rotating, and this will help to move the motor. And on this principle, our fan, our machines, washing machines, uh, you can say mixers, okay, anything which moves around, or any motor, DC motor, works on this principle. Okay, now coming to the next drawing, you have to draw the magnetic field lines around the bar magnet. So you have to draw the bar magnet initially, right? And you need to decide which is the north direction, which is the south direction. If this is the north and this is the south direction, you have to name north and south direction. And the next step, what you have to do is you have to start drawing lines, right? So you can draw the lines. Please draw the dotted lines, and the arrow is very, very, very important. We know that magnetic fields are imaginary lines which are coming from the north poles and going towards the south pole, emerging from the north pole and merging on the south pole, right? Here a few lines you have to draw like this, one straight, the other is like this. Okay, so they all are, you have to draw the proper arrow mark, how they are going out, and in south pole they are coming inside the south pole, right? Similarly you have to draw a few more lines over here. North is, from north poles they are emerging out, and south pole they are merging inside the south pole, right? So this is how you have to draw the diagrams of magnetic fields around the bar magnet. And this is all about today's topic, children. Practice today's topic. Thank you so much.